This meeting is being recorded.
Okay, so good morning or good afternoon to some of you. It's great to see many people joining us for this webinar on Semantic Explorer and how it can be used as a text mining tool for smart research. And to discuss this important and interesting topic with me today, I'm joined by two guests. One is Dennis Kolokol of Kayo, who has been the main brains behind Semex. And another speaker is Tula Loiti of Smart and Lean Hub. Tula piloted the use of Semex in Finland in our Finnish pilot, and she even managed to test it together with some of the policymakers, and her presentation will be about that. But before we get there, let me announce some housekeeping rules. This webinar is being recorded and it will be published on the PoliRural YouTube channel. We will also have one poll with 2 questions. This will be the next activity that we do. And please make use of the different interactive features available on Zoom, whether it's Q&A or chat, or if you'd like to speak later, just raise your hand. So all these options are available to you. Please make use of them. So now we're going to ask our audience 2 questions just to understand a little bit better, who it is with us today. I'm going to launch the poll now. I hope you can all see the poll. So the first question is, which of the following best describes your professional background? And you have several options to choose from: researcher, policymaker, business manager, charity worker, farmer, student, or other. So I see 14 out of 22 participants answered the poll. So I'll just leave it open for a few more seconds. So just that we can manage to collect all the responses from everyone who joined us today. "20 people answered, 20 people cast their vote. That's fantastic. And I see that we also have some interesting responses to the second question, which is how familiar you are with text mining. We have one person who said he's an expert in this field.
It's me, shamelessly, sorry.
We also have quite a few people who said they worked on a project that used text mining. Also, one of the participants regularly follows news on text mining. And the vast majority of those with us today said it's the first time they hear about text mining. So that's also good, because hopefully by the end of the webinar, you will have considerably improved your knowledge about text mining, and you will have fun about the different benefits it can bring to your working practices. So that's great. We can close the poll now, and I'll just quickly reveal the results for you so you can all see it. And now, before giving the floor to our speakers, I will quickly introduce the PoliRural project to you, because Semex has been developed as part of the PoliRural project, and there was a specific area in which Semex was used. But let me first give you a quick overview of the project. And PoliRural has been conceived as a policy co-design exercise intended to make rural regions, rural areas in Europe and beyond more attractive. And when we say more attractive, we also mean making rural areas stronger, better connected, more resilient, more prosperous, which is in line with the long-term vision for rural areas that European Commission set out recently, last year. And what makes PoliRural innovative is the unique blend of different concepts, methods, and tools. Our overarching framework is the foresight approach. And we are not doing a future studies exercise, which is simply producing more research. We're doing foresight with the goal of producing actionable results at the end. And these results that we're producing, they must be endorsed by rural stakeholders, and they also must be adopted by key regional actors who will ultimately mobilize funding and implement the proposed measures to make rural areas more attractive. And our approach in the project has been three-staged. The first stage, current rural situation, this has been completed a while ago. And the main activities in this stage focused on understanding the different rural challenges that regions are facing. And here we conducted a number of exercises. One of them was the analysis of drivers that are shaping processes on the ground. We used the steep V mnemonic to understand and gain a holistic knowledge of how different megatrends are shaping processes locally. And STIPI basically stands for society, technology, economy, environment, policy, and values. And then after that, we encourage our local teams to explore these international drivers through a series of deep dive workshops, just to gain an even better understanding of how international megatrends like climate change play out locally. Because in one area, it can manifest itself through heat waves, through droughts, in others through flooding. Somewhere else, it can be, for example, the arrival of alien species not seen in the territory previously. So all this was carried out as part of the rural challenges exploration phase. But also in the current situation stage, we try to assess the performance of rural policies. Before proposing new measures, it's useful to understand how existing measures are performing. So that was exactly the purpose of that policy evaluation exercise that we conducted at the end of the current situation phase. And here we used a number of different techniques. One was more classic, traditional survey-based approach, and the other was the more innovative text mining-based exercise. And the purpose of today's webinar is to explain what text mining is in the context of PoliRural project and how ultimately it was applied in the context of policy evaluation exercise. Then the future outlook stage. This is when pilots, regional foresight teams develop their action plan, and in this action plan, they have to explain exactly what measures they are proposing to address rural challenges in order to achieve the vision that they set out for the region. And the vision can be a 5-year long vision, 10-year long vision, or it can be even aligned with the long-term vision for rural areas, which is up until 2040. And a crucial element of the foresight package is the roadmap, which basically tells who will be responsible for implementing the measure and who will oversee the mobilization of funding and how the different measures are going to be sequenced, when they're going to start, when they're going to end. So all this is captured in the roadmap. And together, the vision, the action plan, and roadmap constitute an important element of the foresight process. And this package actually makes foresight activities action-oriented, because the foresight package must be endorsed by rural stakeholders to gain credibility and fairness, and it must be adopted by key policy actors who will ultimately implement the proposed measures envisaged in the foresight package. And one of the innovative elements introduced in the future outlooks phase has been the system dynamic modeling. This is an approach we took that took us quite some time, because our first step in the system dynamic modeling process was the creation of a model of a generic rural area in Europe. And to build it, we had to develop up to 8 modules covering environment, land use, economy, education. And so 8 in total modules have been developed with just over 300 parameters, 300 variables. And so once this generic model was built, we then customized this generic model to the needs and ambitions and the specificities of our pilot regions. And once the customized models were ready, we asked the regional teams to explore different policy options together with the stakeholders to understand which one of these policy options best correspond with their vision and the KPIs they set out to achieve. And the work on SDM is now being finalized, and we'll present the results of our SDM experiments during the next webinar, which will be next month. And then finally, at the mission stage, which is underway now, it overlaps with the future outlook stage in the sense that the foresight package and specifically measures listed in the action plan, they have to be aligned with the 4 priorities mentioned in the long-term vision for rural areas. So these are making rural areas, as I mentioned before, stronger, better connected, more resilient, more prosperous. Not only that, we also asked regional teams in the action plans to explain how exactly their measures are going to address 4 high-level EU missions. And we picked 4 missions, some of which overlap with Horizon missions, but some of which are additional, because Horizon missions include fighting cancer, they include making oceans cleaner and more sustainable, which aren't directly related to PoliRural, but some missions like climate neutral cities, healthy soils, these are of course related to PoliRural. So in the 4 missions that we are focusing, included are the transition to net zero, then recovery and resilience from COVID, then implementing rather a sustainability model that is based on biodiversity, and also reforming CAP, Common Agricultural Policy. So these are the 4 missions that we ask pilots to consider and align their action plan with them. And then finally, as the project is in the final stages, we're also thinking about sustainability, how to ensure that the foresight package is sustainable. So in order to achieve that, all the regional teams are securing the buy-in of the policy actors. They are organizing high-level policy events with the policymakers and representatives of rural society. We're also conducting a number of evaluation exercises. Some of them are ex-ante evaluation. So we're ensuring that the measures proposed in the action plan are valid, are resilient, are sustainable before they are introduced. And as part of the sustainability mechanism, rural teams have to set up a monitoring body that would ensure the implementation of measures well beyond the funding period of the project. And some of the mechanisms as part of the monitoring tool that we're introducing also include some data-driven digital solutions like rural attractiveness monitoring that will be also introduced in some of the future webinars. And just to let you know that we're now running the second webinar. We had our first webinar last week. This was on a foresight framework that you can see on our YouTube channel. As I mentioned, the next webinar, webinar 3 on system dynamics, will be in July. And then we'll have one more webinar, webinar 4 on the missions and oriented approach that we're trialing at PoliRural. This will also be in July. So I hope that this gives you some idea of what PoliRural is about and what we've been up to throughout these years. And now, without further ado, I would like to give the floor to Dennis Kolokol, who's been, as I said, the main brains behind Semantic Explorer. He's a data scientist and a software developer in Kaya, who will walk you through CEMEX and will run a demo session at the end just to give you a better sense of how it works. So Dennis, the floor is yours.
Thanks a lot. So hi, everybody. I'm starting to share my screen, and I hope you all see it now. Pavel, can you confirm? Is it okay?
Yeah, that's good.
So yeah, my name is Dennis. I worked on CEMEX tool from the very beginning, and basically I was the one who created not only the tool itself, but also the all the requirements to it. So it means that from the very beginning to the very end, I was creating and supporting all the main functions of the CEMEX and managing the team who was involved in development of that. I'll try to compress my presentation in, let's say, 15 minutes, so that another 5 to 10 minutes will give you a brief demonstration of how it all works. So, but what I'm trying to tell in the presentation is that what is it actually, what semex.io is, and how it looks like, and what its main features, and of course who should work with that, so for whom it's been addressed, and what we are going to do next with the product, since it's online for more than 2 years now. Semex.io is an acronym from Semantic Explorer, which means that we feed the unstructured text and we obtain some useful information out of that. By useful information, I mean measurable information, which means numbers, vectors, etc. And on the main web page, you can already see the kind of small number of information extracted from the text. Like, for example, this is the top statistics that we've got 5,600 documents in the library, more than 36 million tweets processed, because we also process social media, not only the texts from the internet. And I'll talk about this in more details later. We've got a number of source types and organizations, and we support up to 10 languages. Well, not up to, we support actually 10 languages in this product. The core of the system, the main feature, is a so-called regional library. So the regional library is basically the collection of the text that is about a certain region. And of course, each text is not limited to a certain region, but also can span over the regions. And the library is the collection of web pages from the internet, as well as PDF or doc files, as well as text files and JSON files, like any kind of textual format, either added to the library by the meaning of crawling. So it means that you can only add the URL and the system will crawl the data, crawl the text from this URL, or upload it manually. And of course, all the features like sorting and filtering are there. And I don't want to step on it anymore any longer, because these features are kind of must have for any system, so we have them also. Now, another big thing, another big feature in the Semantic Explorer is so-called reading list. And so here I'm slowly starting to go more into the direction of text mining than just exploration of the features of the system. Reading list is a collection of links. Every link in the collection in this reading list must be in the regional library. If the link is not in the regional library, it will be added automatically. Reading list focuses on the topics that are somehow common for this number of collections. So there are a number of features that we extract for each reading list. The first and the main and the kind of most important features is the summary of the text. You can imagine it this way. You don't have to read the whole The Great Gatsby in order to understand what this book is about. Actually, the whole content and the whole idea of the book can be represented in, let's say, up to 15 sentences. So the summary of the text is something that our system does. It means that when you feed it the texts, and it can be up to, let's say, 10,000 texts. Well, it's actually, there is no limit. But if you feed it the text consists of, let's say, 200 resources, then it means that the system extracts the most important sentences from the text and represent it in the form of a separate text, which is called summary. It also automatically extract the external sources, and you can think of it as the resources for further exploration. For example, if you are interested in the topic of, let's say, transportation in rural areas, and you have up to 20 resources on that, you can also be interested in what other resources talks about these topics, what other information in those resources. And this is what Semex does automatically. It extracts these resources for you and represent it in a separate list. It also extracts the topics and keywords. Topics are, let me put the difference right in the beginning between topics and keywords, because they may seem very similar. Topics is something that is stationary. There is a static model which shows the relation between several topics, while keywords extracted from the text itself and represents represents some kind of dynamic information. So the keywords depend on the actual text of the no, not like that. Keywords extracted from the actual text of the resource, while topics are being figured out on the text. For example, if you pay attention to the second paragraph on that, there is a following a period from 1990 to 2012 with the study decrease in etc. You see the EU Council as a topic. However, there is no keyword EU Council in that. But the system figured out that EU Council is one of the topics for that sentence. And therefore, this is a kind of stationary information. The list of topics we've got on the server, and it doesn't change through time, but the relations between the topics change. Depends on how important this becomes in the incoming texts. While the keywords will be extracted from the text itself, and I'll show it a little bit later. Another big feature that is realized on the reading list is the creation of custom language model. And I will talk about custom language model a little bit later. Now let's see what applied semantic analysis means. Applied semantic analysis is a semantic analysis which is applied to a certain text. And here we represent the reading list in the center, and I'll just break it down to you where we apply semantic analysis to. So the first thing is aggregated topics. Let's say we've got 200 resources in the reading list, and we don't want to see the topics of all the paragraphs of all the resources in this reading list, or even we are not interested in the topics in each paragraph in the summary, but we want to see what are general topics, what are the most important topics in that. So for that, we've got this kind of histogram where we represent all the topics throughout the whole resources, and we aggregate them to most important. Now, on the axis Y, there is so-called sentiment. Each topic has been measured by a sentiment of authors of the text. And so, for example, the CAP reform can have 30% negative and 70% positive sentiment, which means that in the majority, what is written about common agricultural policy is written in an official language and been positive, while maybe there are some times somewhere in the discussion people are angry about it, and therefore there will be negative responses. I also want to stress that we split all the texts into paragraphs, and we measure all those things that I was talking about, like topics and keywords and sentiments, paragraph based. So all the resources in the regional library are paragraph based. That means that we, if you see there is this red or green marks, and I will show it later, then that indicates whether it's a positive or negative command. Now, another big thing is aggregate named entities, also existing in the level of resource as well as on the level of reading list. I want to just another one time to remind you that reading list consists of the resources. So the regional library is kind of the library, but the reading list is what you get from this library for your for a certain topic. So aggregate named entities means pretty much everything that can be named, which means that it's persons, streets, addresses, water bodies, numbers, dates, etc. We also aggregate them in a separate container, and we show them as, as aggregated part of the text. Aggregated keywords, that I talked about that. And one of those things that we added on the later stage of the development of the project is the word frequency. That means that we not only want to see what the keywords are, because keywords basically represent a phrase, represented by a phrase. It's a phrase that is a keyword, not just a separate word. But we also want to see what are the most popular words. You can treat it as a bag of words, which means that the most popular, the bigger. And the links extracted from the text. So these are basically the core features of what is applied to a certain text. Now, Semantic Explorer also has some kind of more broader features. And one of those broad features is the topic management. Topic management is a set of features that define how topics relate to each other. So you can also treat it as a two-level structures. First, we define how topics relate to each other, and second, we define how documents in the regional library, well, text, can be denoted by a certain topic. Topics are built in the form of a tree. Then it means that, for example, here you can see rural areas, and the topics that are very close to that are rural regions, urban areas, rural communities, remote rural areas, small towns, etc. Each of them has close topics in its own turn, and this is undirected graph, so it means that rural areas can be repeated on any level, which means that you can navigate through topics endlessly. Now, this is how it looks like in the CEMEX. The root topic is here, and there is a tree of topics growing out of the root topic. And once you click on those, you have the list of documents that appear in the library, or the list of social media posts, because we also collect social media posts from Twitter. And let's talk about it a little bit. Social media tracking is something that from the very beginning was considered one of the biggest features, because, well, social media is the posts in social media is the most important source of information of whether people angry or happy about a certain policy or about a certain topic, not only policies. And we finally decided to stop only on Twitter, so we now only track in Twitter, because the majority of the posts in LinkedIn, Facebook, and other social media end up on Twitter. And so due to we just didn't want to duplicate a lot of posts, so we decided to only track Twitter. In the same way as in the regional library, every time we acquire one tweet, we automatically extract topics and named entities from this tweet, which means that it gives us the opportunity to track not only what people talk about, but also what they mention, like, for example, governments and officials and certain addresses, etc. Now, the next thing that comes from named entities is so-called geotagging, which means that we know what people talk about and we can place it on the map. And, well, I'll show it in the moment. It's better to see it. And of course, sentiment analysis, which means that we extract topics and keywords, and we know that how people angry or happy about that. Now, the search and filtering are pretty easy, so we can search by keyword or phrase. And when we search, all kinds of documents included. It's summaries of curated reading lists, it's regional libraries, or it's social media posts from Twitter. We can, of course, filter by topics, ranges of polarity. For example, we want to see only neutral to positive or neutral to negative or only negative posts. And the search is language agnostic. So if you search by a phrase in Spanish and this phrase appears in the English-based documents, these documents will also be included in the search. Of course, you can filter it out later. The system is open, so the architecture is open. That means that you can use some external visualization tool for getting the data from the system and visualize it to your own needs. Like, for example, in this slide, there is integration with the so-called Kibana. Kibana is a main visualization tool for Elasticsearch, and Elasticsearch is a database that we use to store the data. It's fully indexed, so it allows us to search over all the data, regardless of the source of the information, and it also allows us to visualize it in any possible way that is not available through the system itself. I mean, in the system we included some visualizations, but this open architecture of the system allows you to create your own visualization if you need it so. Now, the system is also open in terms of API. API is application program interface, so everyone given the access can access the Semex on a very low level. And this slide is more for programmers. For example, if you've got programmers here or you've got them on board somewhere, and it is possible to allow to access the information on a very low level, so that you could create your own system based on Semex. And basically, Semex is just the example of how you can build the system based on API, because all the functions in Semex are API based. That means that behind every filter, extraction of the data, every semantic feature, there is an API call that returns the data to the client. Now, before we go to use cases, let me briefly switch to the Semex itself and show you a couple of functions that I was talking about. So let's go to the reading list right away, because it's more interesting, and basically each reading list looks pretty much like the resource in the library. They are more or less inseparable. So let's say we've got a topic which is greening. A reading list consists of several documents. In this example, this is a toy reading list. It consists only of 4 documents, of 4 resources, and some of them are, let's say, not so substantial. So you can see when we hover over the document, it shows you how many sentences from these documents were extracted in order to create the summary. So behind each of these documents is a really long grid, let's say. So out of all of them, we extract some sentences, and these sentences represent the separate document itself that you can actually download as Microsoft Word document and use it for your own research. Now you also have all these features, which is topics. And here you can see that each topic is denoted by a small number and the bigger number. Small number means, like this green number, means sentiment. Then it means that, for example, one of the topics of this reading list is agriculture, and it's generally slightly positive. 0.2 means it's not very positive, but slightly positive. There are many topics, of course. So we just, by default, we represent the top 10. But for example, if you see the internal European market, It's just it appears only once, but it's negative. It's minus 0.5. Also, named entities is like you see, event, location, organization, all of those are being extracted in a separate folder, and you can actually see what are the named entities appear in the text. Word count, which means, well, word frequency, word count is pretty much the same. These are the most popular words in the not in the summary of reading list, but in all the resources of the reading list. These words are the most popular. So it means that once you create a reading list, you can see what are the most popular words in all of those resources and how many times they appear there. For example, this one, the word farmer is 46 times, the word contract is 39. Now the keywords is a little different because keywords, as you can see, are phrases. Also, keywords can be used for the search. Once you've got a phrase, you can search by it, and like for example, rice contract farming automatically redirects you to the page with the search, and this search is being performed over all the documents in the library, and they appear as you scroll down. Let's get back to the reading list, and let's see what else we can extract here. One of the most important thing is that you can, once you get this information, once you get the summary, you don't have to see all of these semantic features inside the text. You can also switch them off in order to see just normally flowing text. So you can switch all of those features off, and you can see just just text. What you're left with is these small numbers, which shows you whether it's positive or neutral or negative, which means a sentiment. So for each paragraph, as you can remember, for each paragraph we denote that how positive or negative the tone of this paragraph is. And another big feature here is polarity score, which shows you, well, in this toy example, the majority is basically positive because it consists of official resources, but it shows you the summarized score, summarized sentiment over all the topics that is available, that is extracted for, not extracted, set up for this document. And the same thing exists for the keywords. So either you see the keywords as a list, and the same with topics, or you can create a polarity score which shows you how negative or positive each keyword or a topic is. Okay, I want to briefly stop on the Topic Explorer because it's one of the most important features, and I think I'm slowly running out of time. So Topic Explorer is something that lays actually in the core of all the interconnections between texts. For example, when you start looking for something, let's say rural areas, automatically you see the topics that system proposes you to pick up, and then rural areas now is the root topic, and you can see which of those topics are close to it, which means that you can also click on each topic and make this topic like a root. So now the disadvantages areas is the root topic. Every time you click on the topic, you also see the number of documents on that. So for example, some of those topics like, for example, this one, rural population. When you see this icon of the documents, then it means that there are some documents in the library on these topics. If you don't see this icon, it means that the topic is just for the connection between topics. So when you click on this icon, you not only make the, well, you actually can see the number of documents, well, the description, the short description of these documents in the library, and of course you can go to the document directly. So that means that in this document there is this topic. Well, there are many more features in Semantic Explorer. For example, the polarity score, which works for all the documents. It's not on the level of the library or a reading list, but all the topics extracted from all the documents in the library are represented in this score. And if you click on a certain area, you not only see what are the score, but you can also see what are the documents. For example, in this particular case, there are many of them are tweets. So it's information coming from tweet. And as I showed you previously, each tweet has a polarity, and there is a number of topics on each tweet. One more thing that I wanted to show you is that in the library, every time we process some document, every time each document added to the library, we not only extract all those features that I just described, like sentiment and topics and keywords, etc., and named entities, we also place those on the map. So these are the places on the map that are mentioned in these particular paragraphs in the library. Well, I guess this is it for me. And I think if you have some questions, it is better to add them in the end of the session. And by this, I switch to Pavel Kovac. Thank you very much.
Thanks, Dennis, for this very good, extensive overview of what Semix is, what it can do, and I think the demo at the end really helped to visualize and better understand what what Semix is from a user perspective. So yeah, let's get back to the use cases, and the next speaker will be Tula Loiti of Smart and Lean Hub. And I know, Tula, you've been contributing to research and development and innovation of Hammer region for almost 20 years, and you've been an invaluable asset in the PoliRural project, supporting and contributing to the Finnish pilot in Hammer region. So over to you, and look forward to hearing about the use of Semix by your stakeholders.
Thank you. Thank you. Before I start, I have to say again to Dennis that you are a great teacher. Again, I learned something new. I didn't know all these small features which you showed there. So keep talking, because you have something to share. Yeah.
Thank you very much.
Thank you. Now I will try to share my screen and start the presentation. Okay, let's see what I have here. Okay, so I'm going to introduce you 3 feedbacks from my region. I interview only 3 policymakers which are working for my region, and let's hear what they have to say. And now, if I only can share this slide, let me have it here. So first, let's talk about policy process. The policy process is conceptualized normally in this way. Number 1 is problem emerge. Stage number 2 is agenda setting. Stage number 3, policy analysis and data analytics. number 4 is the actual decision making made by the policymakers. Number 5, implementation, and number 6, evaluation of the past process. According to this kind of a policy process, the associated government groups must first get the particular problem on the agenda. What is the problem, and put it into the agenda, analyze the problem or the challenge, and then the policymakers made their decision and implement the decisions later on. It seems that in practice, this is because it involves many partners, many bodies in the government. It is not so straightforward or simple process, and there are some uncertainties and biases and all kinds of things. And that's why it seems to be that later on there is more and more demand on scientific evidence behind the decision making. And that's why multiple policy tools such as expert reports, consultation, cost benefit analysis, data analysis are employed by government to provide such decision support for policymakers. And now text mining can be one of those tools to help policy process, to help authorities, policymakers to make better decisions. And that's why we are working on this topic. The other framework, in addition to policy process, is related to my region. I want to tell how the system works in a very simple way. When we think about rural development, we have heard that the European Commission has set up a long-term rural vision and objectives. That is the top level vision and objectives. In the second level, from the top, there is policymakers in NUTS 1 level, governmental, national bodies. The second one is NUTS 2 level. And when we look from the region of mine, then we talk about southern Finland. Then we go to the fourth level from the top. That is Häme, a province of Häme. And we have there several policymakers, authorities who think about Häme region totally. For some historic reasons, Häme is divided to 2 counties, Kanta-Häme and Päijät-Häme, and that's NUTS 3 level from the European Commission point of view. And we have some authorities as well there. When we go down, we find 10 municipalities from Päijät-Häme, for example, and 11 municipalities from Kanta-Häme. And under these municipalities, we can find several active or less active villages. Well, when we think about policy making and change making in Europe, in Finland, we have to reach out all these levels and align them. We need to communicate and negotiate how to make the change for the future. And for me, as a citizen, it seems to be quite tough work. I really don't know how this system works, but this is the system in Finland, and it doesn't seem to be very fluent all the time, but we live in it. I wanted to share this image mainly to show what is the working field of those 3 policymakers that I interviewed for the text mining analysis. They come from the biotime region, which is the right side here, and they represent municipalities. So these guys are from Asikkalalahti municipalities, and they work for that region. A couple of words about the methodology of the interviews. Simply said, semi-structured interviews. It is explained on the left side. I will not go through that. During the interview, I demonstrated from Semex only a couple of features. The topic explorer, which is the image here, you saw it from Dennis' presentation as well, was one key point, and then polarity score and the data analysis were in the core of our interview. And of course, I gave a general introduction of the Semex. The interview was about 1 hour, and there were not many questions, but I think we found some interesting talks around this topic. Now, the first politician that I want to introduce, I don't use names, I just give a profile, is the youth politician. Very young guy. He is working for the university as a politician. He's involved in political youth organization. He was candidate for municipal council, very, very active in local policy making in a back office. He's a student for Faculty of Social Science. So it's a hobby and maybe also a future work. Male, and for sure, digital native. He had no experience of text mining before our discussion. And what I want to say about his thoughts is the concern of the reliability of the information. Is it really trustworthy analysis when it is done by using text mining? That was the main concern. He thinks that text mining can be a tool for the future, but is it reliable? Is it really working? What is the responsibility of the user and what is responsibility of the application producers? Is it possible to get the wrong information through text mining? So he had doubts, but he was positive. In generally speaking, as a policymaker point of view, the important things is to find out the essentials, to identify them and prioritize them. So this is something he expects from the text mining. Go deep to the core and help decision makers to make right decisions for right topics. Yeah, this was youth politician. The second profile, the community activist. She is a member of Municipality Council in Lahti. She's a newcomer into the policy arena. She has been very active in culture, in arts, in associations. She's everywhere, working for the community, and now she is in a political arena as well. She had no experience of text mining before. That's fine. And what are the thoughts about text mining? She wonders how to catch those issues, things which she now reads between the lines when she studies documents which are produced by municipality officials. Is text mining able to do the same or not? Reading between the lines. And as a newcomer into the policy arena, she has faced a serious problem with large amounts of information she's facing every day. Before every meeting, municipality officials are providing a lot of papers, reports, and she's trying to study them all, which is not possible. And she wonders now, would it be possible to get some help from the text mining to go through this information and get the essential part of these official documents? So she's crying for help to cope as a newcomer in this political job. Yes, that's community activist point. Then the third interview, the profile is old folks. And that is because the guy was very, very experienced in the political field. He's now second deputy chairman of the Municipality Council. He has a long experience, not only as a policy making, but also as a worker for the municipality, as an official authority. So he knows both sides, the governmental side and the, let's say, policymakers side. Regarding text mining, there is no previous knowledge. The old folks told about the role of municipality officials, how they can influence on the policymakers' possibility to adapt the information. Municipality officials could produce to policymakers easy to adopt abstract research summaries, but they could also work in such a way that the documents are not easily adoptable. You see, this is about power. The municipality officials may use knowledge as a power to province to show the right way to policymakers. So there are games always going on in the back office, and municipality officials are part of that game together with the policymakers. The old fox was very curious about how the text mining machine really works. And he was very curious to see what is the future. And also, is it really usable for the policymakers, or is it only an academic challenge? He was also asking about these weak signals. Is it possible to find these in the same way as the lady policymaker who was thinking about reading between the lines? So these three interviews were made. As a part of the interview, I also asked numbers to assess their feelings about using Semex or understanding the text mining, generally speaking. The maximum number was 5, and these guys were giving 4 or 5 to all answers. So they liked it, but I have doubts that this is not very reliable result. But just for your information, they liked it. And they are planning to use it and planning to explore text mining also in the future. 3 last slides after action review. The first slide is about the methodology, how I carried out the interviews. It was surprising for me that these guys were very easy to tempt into the interview. They were curious. They were willing to listen what I have to say. And they were very open to give their opinion. That was surprising to me. They were good guys, sort of, and very easy to interview. I think that I could have prepared a little bit more the interview by bringing in some real life case so that it would be easier to talk about text mining with these guys. I had a couple of examples when we looked into the Semantic application, but that was not quite enough. So there's some reason to improve the methodology itself. Yeah, that's about methodology. Then a couple of other comments. The 3 policymakers brought up different kind of issues. Just to repeat, the reliability and responsibility are important words. Can we trust what text mining brings up? And who is responsible of the results or of using the results? That seems to be a tough question, at least for the youth politician. The community activist wants to get some help to deal with massive amount of textual data. And that's important because if the policymakers have no time or energy to go through all the back office output or relevant information, what is then the quality of the decisions? And the old folks understands well the political power of municipality officials. How officials will be part of this kind of text mining usage in the future, or are they? I don't have answers of the future of Semantic in this context, but I have some questions for sure. The reliability and user-friendliness is one key point. It must be in a good shape. That is for sure. The curiosity and interest to understand, explore, test, use text mining is pretty high based on the sample of 3 policymakers. They are eager to know more about this tool. What is the right target group? Is it policymakers? I think that it's not. I think that it's more officials behind the curtain, or it is somebody else, for example, from the research body or university or something like that. But policymakers as a text mining users itself, it doesn't quite fit into my thoughts. And the last question, which steps in the policy process would benefit most from applying text mining? My opinion is that the steps 1, 2, or 3 are the most relevant. Evidence-based decision-making, which is the 4th, it doesn't need any more text mining because the work is already done. Implementation and evaluation, well, maybe evaluation can benefit from text mining, but implementation not. Yep, that was my message. And now it's time for Pavel again. Thank you.
Well, Tula, thanks for this excellent presentation. You certainly raised a lot of interesting points that we can address in the Q&A part. I think it's clear that the policymakers you talk to, and you did attach some very interesting and maybe sometimes provocative ideas to them, especially the Fox one made me laugh. So I think to me at least it was clear that they do recognize the need for text mining, because the policymakers generally are inundated with massive amounts of information that they don't have time to process. You certainly raised some interest and curiosity in them to see text mining as a potential solution to this problem, and also to other issues. You said in your last slide that it can be used in the exploratory phase of the policy design. Also, I think in the evaluation phase, where once the policy is implemented, I think you can apply Semex to the analysis of social media posts that maybe talk about the policy that is being trialed or implemented. So yeah, you touched on so many interesting points, and the very important one is about reliability and accuracy. And I think this is where we would need a view from Dennis on how generally text mining experts address this concern or maybe this criticism about the tools, or the need to have a reliable text mining tool. So maybe Dennis, you can tell us what has been done in the context of PoliRural process to improve the accuracy and reliability of Semex, and in general, what approaches are being taken, what features are being introduced in text mining tools to address this issue.
Yeah, okay, thanks. I think that the answer to this question can be quite short, because every time we mention some real world question like the liability of the sources, we also have to immediately arise the question in which unit of measures we measure liability. So that's the idea, like if the text is not reliable itself, then it's really difficult to say that the text is reliable or not, just based on the semantic functions itself. We really need to know what does this mean that the text is not a reliable one. Now, if you noticed that when I described Semex in the details, and when I described the main features of the Semex, there was not a feature of, well, let's say fraud detection. As for now, there are a number of algorithms in the so-called artificial intelligence that actually takes into consideration fraud detection. But the problem is that these tools are mainly oriented towards numerical data, not textual data yet. I mean, the situation may change in the future, but as for now, the text mining, and there is a more broader term which is called natural language processing, is mostly focused on getting the information out of the texts rather than estimating if this information is true or false, because it is really difficult to say if the information is actually true or false. It's really vague. Sometimes the information is true for one category of people and false for another. I remember that on the early days of development of Semex, we held a webinar, and there was a curious example of the article from The Guardian, which was named, I don't remember the exact title of the article, but there was a phrase, this stupid breakdown. I don't remember what was that exactly. About Great Britain, I guess, about their leaving the European Union. And the funny thing is that the article was about the older ladies who were voting for it, while the title of the article, which included the word stupid, showed the negative sentiment, which could actually say that this article was negatively charged towards the topic, while in the article itself, the content, the overall feeling of the article itself was positive. So the same thing with frauds. It's really difficult to say if this is a fraud or not, just based on the text. We really need some more defined and more and better established measures for it. And therefore, when we approached this in the creation of Semex, we kind of agreed, well, silently, because there is basically no ready tools now, and the time frame of the project wouldn't allow us to create ones, because this is a serious research task, much bigger than the development of the product. We kind of agreed that it is a part of it is a human part to define if the source is reliable, and therefore user enters or adds the resource to the library, and then it means that we treat it as a source, as a reliable source. While one of our tasks in our task list is actually try to define the number of criteria and try to apply them to the social media data, because in social media the issue of the reliability of the information is really high. And so there are a couple of such ideas. If I tell you the phrase normal distribution, it might tell you something, might not. But basically the idea of the reliability based on normal distribution is one promising idea, although it would take some time to implement it. So right now it's still in the phase of conceptualization, and I guess in a few months it will become it will change to the phase of implementation. There is not yet a function that defines the reliability of the source in Semex, because there is no universal reliability yet. So I guess I answered your question.
Yeah, I think if I understood correctly, then the results that you get are true and reliable to the extent that the sources you put into Semex are true and reliable. And then also you need some kind of human verification at the end to make sense of what the results are showing. So we don't leave everything to the tool, and there's some human validation that must happen at the end.
Exactly. If you think of the tool in terms of reliability, then our resource is just a shovel. You wanted to dig a hole in the ground, so you take the shovel. But if you consider the semantic features of the text itself, then it's pretty intelligent. So it's more like, if you depends where you shift your point of interest. If you're interested in keywords extractions, custom language models, etc., then the tool works pretty well. But in terms of reliability, there is no this feature yet there.
Just to add here, it's about how to sell this product to the users, whoever the users are. What are the key points? What are not the key points? And it should be considered very carefully how to express the usage of Semex. That is my opinion. Of course, yeah. It doesn't solve all problems. No, not indeed. Yeah.
We have also two questions from the audience, one for Dennis, one for Tula. So maybe we'll start with the last one for Tula. And someone is, actually it's Anita, Anna Selek is asking, do you use Semex for interview text analysis in the Finnish case? So this is a question for you, Tula.
Yes, we opened Semex, we used it. We had a 1 hour meeting, so it was about half an hour when we used Semex. We were talking about the features, but you know, it's a broad application, so we choose only a couple of features to check there. But yes, that was important to show that this is an application and this is how it works. Definitely.
If you allow me a short addition to it, I mean, we are absolutely totally thankful to Tula for an extensive use of Semex and for many remarks on our bugs and problems in it, because without it we would not really create it at all. We would create just a set of API endpoints which would only be accessed by programmers. So thank you very much, Tula, and please keep up bothering us.
Oh yes, I like buttering you up.
Dennis, and it looks like we managed to interest at least one person in trying out Semex, because Maris is asking, what if I want to try Semex text mining? What are the costs to use the program and where do I start?
Yeah, okay, so you start by sending us an email, because this product was developed in the PoliRural project, so it's not an open registration for everybody. But if you send us an email of who you are and what organization you represent, we will add you as a user to the system, and then you will just be able to start using it. The first thing when you start is a library. So you start adding your resources and just see what system makes with these resources, what information it extracts. Then if, for example, you're interested in things like extracting the summary from the big corpus of text, then you definitely should use reading lists. And also, if you are interested in what topics are like the hottest in social media, you can use search by these topics and then analyze the social media data and see what are the emergent topics in social media. It's just 3 examples. There are much more things possible. If, for example, you've got a software developer somewhere around you, you can ask to connect to API and create you some visualizations that we never implemented in Semex. So it's a lot of things that is possible. But first, please email us, and we will respond as soon as possible.
Dennis, maybe you can paste in chat the email, your email maybe, sure, or someone else's emailing at Kayo. Sure. And there's a follow-up question to your answer, Tula.
Yeah, I noticed. No, I didn't do that. But that's a nice idea, because maybe this is what we should do, indeed. Yeah, good idea. Next time I will do it. But perhaps we also need a little bit more data than only 3 interviews to make it more reliable data.
Okay, and if there are no questions or comments, then we can wrap up this webinar. And first of all, I'd like to thank everyone for participating. I would like to thank Dennis and Tula for attending and delivering these great presentations and for answering questions from the audience. And I'd like to thank audience for visiting us today and following us and staying with us till the end. We would like to ask you one more thing. We did prepare a short survey that will open as soon as we close the Zoom system, or you can access the survey by scanning this QR code. And this is just a few questions about Semex. There are just 5 questions in total, so it's a really short survey, and just to see if you gain some interesting insights today from what you heard from our speakers, and also whether you are planning to use text mining in general and Semex in particular in your daily work. So please help us by answering a short survey. And also another thing I wanted to mention is that this was our 2nd webinar. We will have 2 more webinars in July, and the next one will be on system dynamic modeling. This will be on the 13th of July at 3 o'clock Central European time. You can also register for this event by scanning the QR code, and we have some information on that on the PoliRural website. So do get in touch, follow us on Twitter, and do get in touch if you have any questions about past webinars, future webinars, Semex, and any other things that come to mind. Now let me just quickly check the chat. Thanks, John. Thanks, John, for the nice words. Thanks once again, everyone, for attending. Have a good rest of the day, and we hope to see you at the next webinar. Thank you. Bye-bye.
Thank you very much. Bye.
Thank you. Bye-bye.